Good morning, dear students. Today we'll discuss about ozone formation as well as depletion. Now, the formation of ozone in the atmosphere. So, how does ozone forms in the atmosphere? You know very well that the ozone is the absorber of UV radiation and is broken into an atomic and molecular oxygen. Now, oxygen is present in the atmosphere. So, as the UV radiation strikes on the surface of an oxygen gas, it will be split up into two molecules of nascent oxygen. So, the oxygen which is present in the atmosphere will react in presence of a UV radiation, and it will be broken, split up into two molecules of nascent oxygen. And when the nascent oxygen forms, that nascent oxygen is a very reactive an oxygen, and that nascent oxygen reacts with the oxygen gas again, and it will form an ozone. So nascent oxygen reacts with the oxygen molecules and it will form an ozone, and formed ozone slowly split up into an oxygen gas and a nascent oxygen. A continuous equilibrium is maintained between the oxygen present in the atmosphere and the ozone formed from the atmosphere. So a dynamic equilibrium is set up, due to which the concentration of ozone in the atmosphere remains constant. So the oxygen gas in the atmosphere reacts with itself, splits with itself, and forms a nascent oxygen. Nascent oxygen reacts with the oxygen molecules and gives rise to an ozone. This ozone again splits up into an oxygen and a nascent oxygen. A dynamic equilibrium is maintained. Now this ozone layer protects the earth from the harmful UV radiation because it will absorb UV radiations in the splitting process, and if the concentration of this ozone is reduced, so that is what is called as an ozone depletion. The UV radiations will not be used up, and it will come into the atmosphere, from the atmosphere to the ground earth surface. Now this leads to the rotation of the eyes and skin cancer, and damages to an immune system in the human beings, and especially in the agriculture, it decreases the productivity of the crop. Now the ozone depletion. So ozone causes for the ozone depletion is the use of freons. So you heard about freons. Freons are nothing but ozone depleting substances. So we generally call as the OZDs, so ozone depleting substances. One of the ozone depleting substances is chlorofluorocarbons. Now these chlorofluorocarbons are used as a refrigerants, as an aerosols, and industry it is widely used as a solvents. Now CFCs are non-combustibles and highly volatile, and they reach the atmosphere without broken down, and when it reaches the nearer to the surface of the ozone, the following free reaction takes place. Now these ozone will get depleted. How it will get depleted we'll study. Now the primary molecular structure of chlorofluorocarbons, the first step is the photodissociations. So these chlorofluorocarbons, Cl2F2 is the molecular formula of chlorofluorocarbons. So you have a chloro Cl2, fluoro F2, and carbon chlorofluorocarbons. Now it undergoes photodissociation by reacting with UV radiation. Strong UV radiation will split up the chlorofluorocarbon. So it releases the free chlorine. It releases the chlorine free radicals. So chlorofluorocarbon CCl2F2 in presence of UV radiations, it will form CF2Cl and releases free chlorine. Now this free chlorine, once it is released from one molecule of chlorofluorocarbon, in the second step it will combine with the ozone. So the free radical which will be liberated which will combine activate the ozone, I can say, in the step 2, depletion of an ozone. So these activated chlorine will chlorine free radical react with the ozone, and it will form a ClO plus O2. So the ozone will degrade into ClO plus O2. Now this ClO free radical will react with the nascent oxygen, because the nascent oxygen is the raw material for the synthesis of an ozone. So this nascent oxygen will react with ClO, and it releases the free chlorine free radical, and forms an oxygen. So a cycle is established. Free chlorine is liberated again. This free chlorine again catalyzes the splitting of O3 into ClO free radical and releases the oxygen. So the a cycle is maintained once one molecule of chlorofluorocarbon undergoes decomposition in presence of UV radiations, and it will form uh, a chlorine free radical. Once this one chlorine free radicals is able to deplete complete ozone which is present in the atmosphere. Thus, these CFCs reduce the concentration of ozone over a particular period of time. And very interesting part of this reaction is that in each step, the chlorine free radical is regenerated, and the regenerated free radical is sufficient to react with the ozone and forming ClO free radical and an oxygen. Now, ill effects. Ill effects is when the ozone concentration decreases, UV radiation will penetrate into the atmosphere and reaches the surface, and it will cause an eye infection, skin cancer, and decreases the productivity, that is photosynthesis of plants. Now, temperature on the Earth's surface is raised because of the excessive UV radiations, and control of ozone depletion. Now, ozone depletion to control is the first remedial control is to avoid CFCs. Chlorofluorohydrocarbons should not be used in industries or as a refrigerant, because once one molecule is sufficient to completely destroy the entire ozone.